Hi, my name is Dan Low, and in this video, I'm going to show you some competition problem, from somewhere, okay, for the high school programming competition. Okay, so the problem is this. Uh, the title is Accumulation of Wealth. So a family's wealth is accumulated from generation to generation, typically. Suppose the following formula describes how fast a family could accumulate their wealth. So they say the function g of 0, the 0th generation, you don't have anything 0. Okay, just like me. When I come to the United States, I don't have any savings. So my wealth is 0. That's the 0th generation. And the first generation, g of 1, you'll get 1. Okay, and g of 2 is 2, g of 3 is 3, g of 4 is 3, okay, and so forth. And then g of n is equal to g of n minus 1 plus g of n minus 2. So this actually is called a Fibonacci series. Okay, so Fibonacci series basically it's a the number is the sum of the previous two numbers in the series. Okay, so your job is to run a program that accept input, the generation number, and display the accumulation of wealth of this generation. So here are some sample inputs and outputs. If input is 1, g of 1 is 1. Input 3, and then g of 3 is 2. Input is 8, g of 8 is 21. So there are at least two ways to implement this. One, you can use as recursion. Okay, very straightforward because this is recursion relation. Okay. Another I'm going to show you is iterative, using a loop to do it. So let's start out with the iteration. Not iteration, sorry, recursion. Okay, so recursion. So basically, recursion is a function that call the function itself. So you're going to define a function. Okay, let's say Fibonacci or FIB. So Fibonacci, let's say accept one number n. Okay, so for the recursion, okay, you need to check when to return to the caller or when not to keep calling itself. So which are the initial conditions? In this case, g of 0 and g of 1. These are the initial conditions because g of 0 you can find the previous two numbers, to compute it. And g of 1, same thing, you only got one previous number which is 0, but you don't have another one. So g of 0 and g of 1 are the initial conditions. So in other words, if the n's value is 0 or 1, then you need to return its value immediately. That's the initial condition. G of 1 is 1, g of 0 is 0. So first thing you need to check is if n is less than or equal to 1. Okay, in that case you return n. That's it. Then if not, okay, then what you have to do, you're gonna return itself Fibonacci n minus 1 plus Fibonacci n minus 2, and that will be your program. Okay, so the program is quite straightforward. Okay, so let's run it. So you can test the program by putting 1. Okay, it gave you 1 and 3. It gave you 2. Okay, and then you check 8. So it passed 3 cases. F8 is 21. Okay, you can put a 10. Okay, 55 and so forth. Okay, so that's the recursion version. And next I'm going to show you the iterative version. Okay, or loop version. So for the loop version, if you observe the regularity, okay, so the you're going to have a loop go over the previous generations all the way to the generation you're going to find out. So for example, you want to find g of 4. Okay, So you first have to start out with the g of 2. So g of 2 is computed by the sum of previous two numbers with g of 0 and g of 1, with 0 plus 1 is 1. Okay. Then g of 3 is computed by g of 1 and g of 2. Okay, so it's 1 plus 1 and 2. And g of 4, then you can compute g of 3 plus g of 2, which is 2 plus 1 is 3. So the loop in your start was 2 all the way to the generation you're going to find out. Okay, so here is the program. Again, we define a function, say Fibonacci iterative. It receive one number. Okay, and in this case we're going to check the initial condition as well. So if n is less than equal to 1, okay, so you can just return n immediately. You don't need to do anything. Okay, if n is not less than or equal to 1, okay, then you need to have a loop. Okay, have a for loop. Okay, so yeah, for loop I in range. So let's start with 2. Okay, 2 n plus 1, because you want to find g of n. Okay, but this range will go from 2 all the way to n if you set it to n plus 1. So it's 1 less than the number you put here. Okay, so in the loop, so what you have to do is that you need to have two variables, keep the previous two values, okay, in the series. So I'm going to use a gn minus 1. Okay, so in g minus 1, the beginning initial value should be g of 1. Okay, so it's 1. And gn minus 2 is the beginning value of, if you start with 2. Okay, then this gn minus 1 is g of 0, which is 0. Okay, we need to keep that. Okay, initially, then this should be outside the loop. Okay, not inside the loop. So let's get it outside, because that's the initial value. So you put a comment here, say initial values. Okay, okay, so you set it this 2, and also you need a return value. Okay, return value, you don't have to do it here. You don't need to initialize, because you need to compute it here anyway. Okay, so now so for I equal to start I equal to 2. Okay, so you first compute return value. Okay, so return value is gn minus 1 plus gn minus 2. Okay, g of n minus 1, g of n minus 2. I just use this for the variables, okay, to keep it. So after you compute the current generation, you're going to compute it. Now you need to adjust the gn minus 1 and gn minus 2. So gn minus 1 will get gn minus 2. So gn minus 2, okay, will get a gn minus 1. So you assign gn minus 1 to gn minus 2, and then gn minus 1 will get the return value. Okay, because that's the new value we computed. It become the gn minus 1 for the preparation of the next iteration. Okay, so at the end, then we have the value in the return value, so that return it, and that's it. So after the end, so return val. Okay, so that will be the program. A little bit complicated, but it's manageable. Okay, so now we test it out. I need a code block. Okay, so there's another code block. Okay, so let's run it and print it. Not assistant, sorry. Print 5i, let's say 3. This will give you 2. Okay, and 8. This will give you 21. Okay, very good. So that will be the program. Okay, and if you like it, thumb up, share, subscribe, keep comments. Thank you. Have a good day. Bye bye.